So welcome everybody to today's webinar. My name is Nikki Moline. I'm the Energy Programs Director at Walking Mountain Science Center. Our webinar today is about ductless mini-split heat pumps and specifically about how it can save you to get a ductless mini-split heat pump, cold climate specifically, to replace your electric baseboard heating. Our sponsors today are shown at the bottom of the screen there. Love Electric, that's loveelectric.org. You should check it out. The Climate Action Collaborative here in Eagle County, the Colorado Energy Office, CORE, the Community Office for Resource Efficiency, Energy Smart Colorado, Garfield Clean Energy, Walking Mountain Science Center, and Holy Cross Energy. So first, I'm going to tell you a couple housekeeping items. We have a Q&A box. You can click on that link at the bottom of the page, write your questions in there throughout the webinar. We'll have plenty of time at the end to ask Dave some of those questions, if not all of them. You can also type whatever you'd like in chat. Mary and I will keep an eye on both the chat and the Q&A, and we'll do whatever we can to help you out throughout the webinar, as well as answer those questions at the end. I am going to hand it over to Mary to introduce our presenter today, and enjoy the webinar.
Thanks, Nikki. Hi, everybody. I'm Mary Weiner. As Nikki said, from Holy Cross, I administer the energy efficiency in electrification programs, which is a mouthful. So Dave, obviously, Dave, you're a skier because we've been talking skiing lately. So Dave Petroy is coming from us from Boulder. So it's great that we can Zoom and it doesn't matter where you're sitting. I'm actually sitting outside at our offices in Glenwood. So Dave has an MS in geophysics. He used to own a company that did geothermal, which we call ground source heat pumps. And now he's really getting into the heat pumps, whether they're ductless or ducted. And he now owns NTS Energy and is consulting with us and helping us get to that transition of electrification and heat pumps. Even if you already have electric heat, you're going to be impressed with what these heat pumps can do. And if you have been outside lately and noticed the smoke, cooling and the air filters that these heat pumps offer is also a great benefit. So you get two for the price of one. So Dave, take it away.
Thank you, Mary. Thank you, Nikki. So today we're going to talk about mini splits, and in particular, a lot of you, how they can help you with electric heating bills with baseboard. So I got about 24 slides. If I talk super fast, that would take 15 minutes, but I try to keep it reasonable, and it takes about half hour, maybe a little bit less, and then we'll have lots of time for questions about your specific situations. So we're going to go over the heat pump technology. What is cold climate? We'll talk about mini splits. We'll talk about strategies, ways to look at your home, think about your home. How can I incorporate this? We'll talk possibly about additions and remodels also. And then we're going to talk about how do you get a good system? You go out, you say, I really want to do this. What is it going to take to get a good system, and some tips, and then some resources. So lots of stuff to cover. First off, for those of you who aren't familiar with what a heat pump is. Heat pumps have been around for quite a long time. Actually, they've been sold for homes since the 1950s. But what they do, they concentrate and move heat, not temperature. So that's the first thing you got to kind of get out of your head is don't think temperature, think heat. And cold air, even -10, has plenty of heat in it. It's just diffuse. -460 has zero heat, but we don't get that cold. An air conditioner is just a one-way heat pump. So let's just go through this little diagram, and there's lots of videos, one on Love Electric, more detailed. But what you have, this is the outside unit. It's called the evaporator, but it's the unit that looks like an air conditioner. And there's refrigerant that goes through it, and it's actually cold when it gets into this unit, below zero. What happens is it's in a coil, it goes up, and there's air blowing by it, and it's going to pick up heat, even if it's -10. It's still colder than that. And the amazing thing about refrigerant is it loves to absorb heat and give it up. It's a unique property of it. If you put it on your stove and put some heat on it, it would boil pretty quickly. So this warm refrigerant comes out here. Now it's got to be up to about 100, 110 degrees really to warm our house. So it's not quite that hot. and it gets compressed. So we do add some energy in the fall and the spring when it's pretty mild out. We have to add less energy because this comes in warmer. In the winter, in the depth of winter, we have to add more energy. The result is this is a nice warm gas, about 110. It comes into the house, and you have a unit inside, which is, well, the mini splits are wall units, different kind of units. Ducted ones look like furnaces. What happens? There's a coil in there. This is warm. It's a gas. Air blows by that coil. It becomes warm. It heats up your house. The refrigerant cools down, goes back out. Now, one thing about this area you need to know is it's around mid-90s air temperature. So it's about your body temperature. And when a lot of times when people put their hands up to heat pumps, they say it doesn't feel warm. It's not going to feel warm like a gas furnace or that. But think about it, 95, 98 degrees is much higher temperature than what you're trying to get the room to 72. So it's just something to know about. This comes out here and it comes into expansion valve. And when these gases expand really quickly, they become very cold. It has to get cold, and it's cold, and the cycle repeats. It goes and absorbs more heat again. So it's a very, very simple cycle. It's been around a long time. But what hasn't been around a long time are cold climate heat pumps. And I use the term classic as heat pumps sort of before the turn of the century, where they were designed. They've been in since 1950s. They really weren't made to work when it was cold out. Classic heat pumps weren't made to work below freezing. Basically, it was in mild climates in the South. They cooled, and then they would heat when it's mild. But around the 2005, I'm going to call it the birth of the cold climate heat pump evolution. And there was engineering improvements to all the critical components. People started to think about it and said, well, there's no reason that heat pumps can't heat when it's very cold. We have to make sure they can defrost. We have to make them more efficient. We have to make them be able to heat more in colder temperatures. Well, there was a lot of work to start in the US because heating oil became expensive in New England. And Europe and Japan had also expensive heating. And so all this engineering work made these called the cold climate heat pump. So between 2005 and about 2010, there was all this design, all this research, all this effort, and then they started to install them throughout the US. And right now they're all throughout the US, actually tens of thousands of installations. New England, Minnesota, Canada, all over. This map here shows our climate zones, and what we're talking about now up in the high country, obviously climate zones 6 and 7, very cold, but the cold climate heat pumps work very well up here. And we'll talk about in the next couple slides some specifics of how they got the improvements. But first thing I think that a lot of people aren't aware of is it's natural to think that a lot of your heating energy goes when it's really cold, but that's actually not true, even up in Eagle. So down here is the outdoor temperature, which goes from -20 to 65. And this is how tall this is. The left axis is percent of annual energy use. And you can see that down about 35 degrees, 1/3 of the heating energy, the bulk of it is between 35 and 15. And then about 18% is below 15 when it's really cold. Now, classic heat pumps used to just do the orange. That's why they really weren't good for cold climates. They didn't really do much. Cold climate heat pumps can easily go down to 15 degrees, and most of them are designed for 0 and even down to -13, -15. So cold climate heat pumps can now do almost basically the bulk of the heating, even in the coldest, even in our cold climate zone 6 and 7. A couple of terms so that people who aren't familiar with terminology: heating tons is at 12,000 BTUs per hour. And most homes are in the range of 3 to 6 tons. So you'll see that on the next slide. It shows how much heating, 36 to 72,000 BTUs per hour. SEER, I think everyone's familiar with. That's a rating of how efficient some is at cooling, and heat pumps do cooling. Range of equipment is 15 to 24. 24 is half of 12. This is a big thing for heat pumps. How do I know, the different levels of heat pumps. It's heating season performance factor. And it basically says over a standard heating season, how well does this unit heat? The higher the number, the better. And then I will show that on the next slide. Coefficient of performance is actually how efficient is a piece of equipment under certain conditions. And this is a nice way to compare different kinds of heating systems. So furnaces are COP of 0.9 to 0.8 to 0.95, like 80% efficient, 95 efficient. You're running electric strip heat in your homes, which is a COP of 1. The heat pumps we're talking about are COPs 3. Some are even higher than 3. And 2 uses half the energy of 1. So we'll show some examples, but basically these heat pumps use about 1/3 the energy that you're using right now electrically heating your homes. And this shows how these heat pumps have improved. Remember, I said about 10 years ago or more, we wanted to get cold climate heat pumps. So the left axis is this heating season performance factor from 0 to 14. And these are every 2 years, 2012, 14, 16, up to 20. And about 10 years ago, 8.2 was the best you could do if you went out and bought a cold climate heat pump. But every couple of years, the heating efficiency improves. And now it's all the way, the best units are 13. Most manufacturers, the cold climate heat pumps are in the range of 10 to 11. And notice, an 11 heat pump is 34% more efficient than an 8. And even a 10 is 22. So basically, these are about 1/3 more efficient, 33% more efficient than they were only 8, 10 years ago. So this is the continuous improvement of heat pumps. The second thing, and this is a little bit busy, but let me just try to make it simple. So the left axis going up is how much heat your house needs. And the bottom is outdoor temperature. So basically in the green line is a home and it says, okay, at 60 degrees, I only need 5,000. All the way up to 0 degrees, I need 60,000 BTUs. So 12 times the amount. These curves here, this is a heat pump heating curve. So back about 10 years ago, I followed the low blue line. That's how good, that's how much capacity they could heat. And notice below 30 degrees, my house needed this green line. My heat pumps, which weren't cold climate heat pumps, could only do this bottom line. And all of a sudden, when I'm at 10 degrees, it's like, whoa, this heat pump doesn't have enough juice to heat my house. Well, technology improves. Big jumps with cold climate heat pumps. And now most of the heat pumps are up in this sort of light blue wedge. And actually the mini split ductless are sort of near the top of that wedge. So at 10 degrees, wow, I got a lot of heating out of this heat pump. And I have a little bit of a wedge left, not much. And that's where you would just use your electric baseboard to supplement a little bit. So this is the second big improvement in heat pumps. And the third one, which I don't have a diagram, but is the ability to defrost. So when it gets cold, basically 32 and below, the outdoor unit starts to freeze up. They can go into defrost mode and work well. So mini split, multi-zone mini split heat pumps is what's really going to be helpful to you. And these are called ductless. And what it means is there's an outdoor unit that's going to be similar size and shape to an air conditioner. Might be a little different shape, but basically similar size. So into your home, into each room or section of your home, you have an indoor unit. I'll talk about these later. Wall units. Oh, sorry, that's a mistake. Wall units, or there's other kind of units. So from the outdoor unit to the indoor unit is basically 2 refrigerant lines run to that unit and a power line. And they only take up 6 inches of space maximum, 4 to 6 inches of space. So that's what's really nice about being able to get these and retrofit them into your existing homes. So you can have up to 4 units, indoor units, off of one of these units. And each zone is independent and it can be controlled It's got sort of, a lot of these have remote controls or thermostats, and they're very, very quiet, like 20 degrees, which is rustling leaves or a whisper. I've slept in many bedrooms with these, and you can't really hear them. So aside from not having ducts, the other thing is there's many different ways you can fit these into your home. I talked about the wall unit. Then they have what they call floor units, very lower units. They have these units in the ceiling, which are nice. These are cassette units, which are great for the second floors. You need to have a little access in the attic or in a low closet, drop ceiling or something to put these in. So these units here are great choices for middle floors, because what you can do is those lines can go along insulated conduit in the outside walls, come right through and connect into the back of these units. This unit's here good for the second floor. As I said, you need something above. The other advantage is you've got air filtering. So in all these are good air filters, and they can be easily changed from accessing the front of units. So that's another thing that these mini splits will bring to your homes, is really good filtering. There's a couple other things recently they've added, and these are slim ducted units. And the nice thing about these, they're only about 8-9 inches thick, so they can actually fit in the attic or in drop spaces. And the clever thing about those is you have a very short little duct system. So they're great for 2 adjacent rooms next to each other. For instance, 2 bedrooms, you could put it up in the attic and just run a little duct and do each bedroom. You could put it in the closet ceiling between them. And so this saves you some money because you've got 1 unit feeding 2 rooms. So it's a very good strategy, and comes into play in a lot of situations. And finally, the last thing they came out with now is units that look more like a standard air handler or a furnace, and you can do ducting to these units, and you can run 3 to 4 rooms off of these. So you could put these, if you have a basement, in the basement, and do a duct system and do a few rooms off of that. But also you can do another unit or 2 upstairs off of these mini splits. So these are ducted units, but they can work in conjunction with the other ones. So now you've got even more flexibility. So adding them to your electric baseboard homes, what are they going to get? How's this all going to work? Well, you're going to cool in the summer, and you get heating all year round. And you're going to reduce your home's emissions. I'll show you that later. And you're going to have a lot of savings. I have an example of that. Now, when you start to think about this, and you say, well, we're gonna talk about when you're looking at your house and thinking about, okay, how can I fit this in? There's sort of 3 things you want to keep in mind. You want to minimize the number of indoor units. I say minimize, but I also added optimize, because you don't want to overdo this. And what I mean by minimize is, for example, on the main floor, you might have a kitchen and a dining room open to each other. And you could potentially, depending on where the wall is and the flow, you could actually put 1 unit on and do both of those rooms very comfortably and nice. However, when you're working with your HVAC partner, they might say, well, you know, it sounds good, but it's not really going to work in this case because the air is not going to flow far enough, or it's not quite big enough unit. So you want to try to keep this in mind. Minimize, but don't overdo it. You want to minimize the lengths of those lines going from the outdoor units to the indoor units. Now you got to think, I'm going to put the outdoor unit here, and I'm going to put the indoor units in certain places. But if you have some flexibility, you want to think about that. And the last thing, which you'll work with your contractor, is the condensate. So each of these indoor units has a little condensate. Typically it runs just to the outside and down, or you might have a pump. So that's something else that you keep in mind. So your priority determines the best strategy. So in these, I think in your cases, in the electric baseboard, most of you driving is, I want to save money on my heating bill. Maybe I want to reduce emissions. Cooling comes along with it. In some other cases, if you're saying, well, cooling's a priority, I really need to cool these areas of my house, and I want to save money, then it's maybe a little different priority. So if you really want to get the most sort of savings for your dollar of a new system, you want to find the largest area of your house that can be served with one or two of these indoor units. And that way you're going to get the most volume, the most heating savings for the least number of units. And each unit, might runs a few $1,000s. If cooling and comfort is as equal or greater than priority, then you're going to think about, well, where is it hot? Often it's the bedrooms and the second floor. And for example, I was showing those slim ducted units. So you could think about, okay, my two bedrooms on the one side of the house, they're very similar. They get hot. I can put a ducted unit up there, and one thermostat will take care of them. And then the master bedroom, I can put its own unit on because I want real control. And then the office, I can put another one, or I can put two slim ducted ones. Or in the main floor, if you say my south facing rooms are very large and they're very hot in the summer, and I spend a lot heating them in the winter, you could think about, if you have a basement, maybe you put one of those ducted units below and have a little duct system under there. So that's the way you want to think about your house. What big blocks can I do? What's the most important areas? So for you with electrically heated homes, actually the savings in the front slides at 30 to 50, it's really more for electrically heated. That was more for like propane. But electrically heated, remember I said coefficient of performance is how effective something can heat. Coefficient of 1 means 1 unit of energy in, 1 unit of heat out. Heat pumps are 3, some are even a little higher. So basically the heat pump uses 33% of the energy of electric strip heat. In other words, 1 unit of energy into a heat pump, 3 units of heat out. And you will save quite a bit on the areas that you choose to heat with a heat pump. In fact, if you think about it, 3 to 1 means you would save in the upper 60s, but it kind of depends on how often you use it and what areas. And so it might not be, perfect, but you're going to save quite a bit of money off your bills. So I'm going to show you an example. And this would be, I have a house and I want to add, I have a big area in my main floor, about 3 tons of heating. So, a few rooms. I want to save money. I'm going to switch heating, and my heat pumps are going to heat all the way down to 5. When it gets below 5, my heat pumps are still going to heat, but I might use my electric baseboard a little bit to help. I'm going to do a couple of units. So this is called Manual J, and I'll talk about a few slides. Basically, this is what your heating and cooling contractor would do to model and say, all right, how much does this home need to heat for these rooms? So I did this Manual J, and this is the amount of heating, 36,000, 3 tons. And then this is your electric baseboards, 100 AFUE, so it means it's COP of 1. And heating, in this case, in a year, 3448 a year. And this is using 10.5 cents a kilowatt hour, sort of the average for a Holy Cross system. And now I've got a Mitsubishi Electric Mini-Split system in here, heating the same thing. 10.6 HSPF, heating season performance factor. Remember on that one slide, I said many of the manufacturers are between 10 and 11. And notice $1,209 to heat that same area. So this is a very expected results. Remember, we're not making heat, we're just moving. The beauty of heat pumps. So I've got that, and I put them in, and I save about $2,200 a year, a little more. Now I can put a cold climate heat pump in, 2 mini splits, and this is the rough cost. I'll talk later about going out and getting bids, but 20,000 is a ballpark. You're going to get a beautiful rebate from Holy Cross, $600 per ton, and so 3 tons, so $1,800. And a lot of the energy organizations up in the high country, for example, Rocky Mountains, et cetera, give additional small rebates. So you might be putting in some investment in the order of about 15,000, but think about the lower cost every year that you're saving. For those of you that are want to be aware of your emissions and how you might help the planet by doing this, this shows how much CO2 emissions, and the left side is pounds per year. And what here, this group of bars on the left side is what's going on in 2020, or what 2020 a year ago, in when the system has about 44% renewable energy. And you can see with 44% renewable energy, electric resistance gives the most CO2, but look at the cold climate heat pumps. Notice a dramatic drop because they use that much less energy per heating unit. Now, what happens over the next few years, and you're buying something that's going to last 15 or 20 years? Wow, if I move to a cold climate heat pump, all of a sudden I drop this immediately, and then by 2027, which is 80% renewable, trending toward 100, I'm way down there. I'm really not putting out much for heating my house. And to give you a comparison, if I went out, bought a $35,000 electric car or more, this is how much I would save versus driving my gas car, about 15,000 pounds. So this really provides you the opportunity, if this is important to you, to really make a big impact. Now, for remodels and additions, you can add just electric baseboards, but there's a lot of the benefits to the mini splits, and they're very simple to add because you can just have very short runs. You put outdoor units, indoor units, you get cooling, you get heating, you get air filtering, and you don't really even, you can size these. In this case, you wouldn't really even need to put in electric baseboards, and they're very flexible. You have all those different indoor units, super efficient, super low cost. So it's a very good way, and a lot of people are doing this now, even if you have traditional gas and other kind of systems, because just getting them in and getting the distribution is so much easier. So let's talk for a minute about getting a good heat pump systems. This is not super new technology, the cold climates, like I said, 10 years, but Colorado the last few years have been really taking off. So let's talk about a few things. There's some errors you can avoid easily, getting a good contractor, how to design, what's a cold climate heat pump, and some installation checks. So in the past, and I think this is a lot less prevalent now, but here's a few things you just want to. So, okay, you want to make sure you get a cold climate heat pump. And I'll define a little more. It's got to work when it's cold, and it's got to produce a lot of heat. Sometimes you want to get manual J used for sizing. So some of the contractors will estimate it. You try to get them, you say, hey, I really would like manual J. They might, you might be willing to pay a little bit more for that because that takes some more time, but you'll get a much better sizing. Design temperature. So some of the things, what happens is the design temperature sizing is incorrect for the climate zone. So they might not use, in your climate, really cold, really high elevation. Make sure they're using the right temperatures. The result would be undersized units. They're sized and they're going to do well, but they're not quite big enough for when it's really cold. And we'll talk a little bit about some installation, make sure that lines are insulated. And sometimes the control settings just aren't set up right. So some of these little errors, which are with great contractors and knowing this, easily avoided. In the past, there's been like, well, some people say, you'll talk to some people say, my heat pump doesn't really work when it's kind of cold. 99% of the time, one of these things happen. And the heating costs were much more than expected. And often that's the simple thing of the control setting. So, and what that means is you get a heat pump for a big part of your house, and you turn the baseboards off. Gets below 20 and the heat pump's not keeping up, you turn them on, but they had the setting in the heat pump so that it was really not set the heat much below 20, which was not the right setup. So contractors, getting a good contractor, this actually, a lot of this applies to just in general HVAC. You talk to folks, the resources, Mary, Nikki, all the organizations up here really working tightly with the contractor community so they can give you great recommendations. I look at the websites, and I actually look at their websites and see if they have anything about mini splits, because a lot of the times they don't necessarily keep their websites quite up to date, but if they really care about it, they should have some stuff on it. You can ask them how many heat pumps they're installing per month or per year, if they've been certified. And my advice would be to get a couple quotes to start, not to go and try to get a bunch. Everyone's very busy and they want to give you a good quote, but they also want to realize that they have opportunity to get some business. If they're far apart, I would get a third quote, and this could often happen. And you want to be really cautious of very low quotes, because really to do a good job, you don't want them to cut corner. And don't compare online pricing with contractor bids. It's funny, online pricings come to everything, even to heat pumps and heating, and you realize you're buying something for 15, 20, 25 years. You want to be able to have it work. You want to have replacement parts. You want to have people to come service it. And this is online purchase. And I've looked into some of these distributors. They really have no history, very little background in HVAC. They're just warehousing parts versus, you know, with the traditional HVAC structure, you've got manufacturers, distributors, reps, a whole level of folks that are willing, want to help. So I've talked about cold climate heat pumps, and how do you know you're getting a cold climate heat pump? So there's a couple simple rules. One is that HSPS, that number needs to be 10 plus, and it operates at outdoor temperatures below 0. So, you know, a lot of the mini splits actually go right down to -13, but clearly all the cold climate ones at least go to -5 or below. You know, confirm with your contractor. You must get a match system. And actually for mini splits, they're always a match system. That's more for ducted units. And check that it meets the requirements. On the last page, there's some good stuff about requirements. You can ask how noisy the units are. I said they're super quiet. And what's the warranty? And I would ask, what, particularly the compressor, what is the warranty? Now this talks about, this is just a little glimpse. How big a system do I need? And so what you want to do is up in your area, in the valley, it's like -6. So they have to make sure they design for -6, but you have to derate the equipment. So you don't have to do it. When your contractor's designing this and it says, I need so many BTUs at 0 degrees, but I'm at 7,000 feet or 6,000 feet. So the unit can only do 22% less. So they got to get generally a bigger unit. In the indoor zone nodes can, if possible, you can balance them. So this is just a little example I showed before. So the green line is how much heat I need. All right, and let's just focus on below 20 degrees. So below 20 degrees, how much heat it is, it's going up, it's going up. Now in the past, this was the problem, heat pumps can only do this much. So all of a sudden you're buying a heat pump to do a lot of your heating, it's not quite able to do it. But now with these mini splits, 20 degrees, 15 degrees, even at 10 degrees, very little. This wedge might seem like a lot, but realize that's only getting down to about 5%, 10% of your heating. And the heat pump's still doing most of it. You're just supplementing it a little bit. And so this is the kind of matching a contractor will do to make sure you get the right size equipment. So indoor units, where to put them. Remember, you're just looking for ways to get these indoor units in. Middle floors, you might put, you know, they're going to run the wall on the walls, outside walls. Top units you can put in the attic. You can go below the basement. And when you're watching them put it in, you know, look, make sure there's no kinks or sags in the condensate lines. And are they putting in pumps? And they got to insulate the line. So if in an attic, if it's not a conditioned attic, good contractors, they know they have to do really good insulation on the refrigerant lines. And they shouldn't have a lot of connections in. So that's just a few things. Outdoor, it's a little bit easier to look at. You want to think about where you're going to put them. This is going to run year round. So I wouldn't put it like under my bedroom window. Or if I use the patio a lot, I'm not going to put it right next to the patio. If you're going to put it on a wall, you want to make sure it's mounted well. Now, if you can avoid the north side or the west wind, that's fine. If not, that's okay. But southeast corner is often a nice place to go. You got to protect these from the snow unless you want to shovel them out in the winter with the protection up high. And mounting these off the ground in your part of the country is very important. And what I do is I say, what's the average snow depth of the maximum month? So Vail, it's like 30 inches. So I want them up high like this. Rifle doesn't have to be high, maybe 12 inches. And you want to have them drained to a good spot. And ask your contractor for pictures of installation. Say, oh, I'd like to go to a few places. Send me some pictures. So let's summarize. These mini splits work great, cold climate in Colorado. They're good. They help for a lot of things. They save quite a bit versus electric. Remember, COP 3 versus 1. Think about your house. What am I really trying to accomplish? What rooms does it make sense to do this in? Go through the slides and, at least you have some basic questions, basic understanding to ask contractors. You can always get help from Mary, Nikki, everyone up there, email myself. I would say find someone who's going to present the options. So when you're calling the contractor and say, I want a mini split, I want to do it like this. If the good contractors, they'll be enthusiastic about it. They'll really want to work with you. And here's the slide with a lot of the helpful resources available to you up in the high country.
Thanks, Dave. Yeah, I want to say thanks again to these very specific sponsors that can offer resources to you and help. So Community Office for Resource Efficiency, you see them listed on there. They have educational info and you can ask them about heat pump rebates and their contact information is there. Energy Smart Colorado, which is a program offered through many of these organizations. Garfield Clean Energy, you can see their contact info there. They also manage the Glenwood Springs electric rebates. Walking Mountain Science Center, we can help you here with incentives and rebate info, educational info provided, and then Holy Cross Energy as well. You'll see at the bottom, there's Mary's contact info. I'm going to hand the next page over to Mary, and she's going to tell you all about real specific Holy Cross Energy incentives that are available to you.
Thanks, Nikki. Thanks, Dave. That was great. Thank you, everybody, for staying with us. So with heat pumps, if you already heat with electricity, so whether you have an electric boiler or electric furnace or electric baseboard, we rebate $600 per ton. And as Dave explained, a ton is basically 12,000 BTU. So get the model number of the outdoor unit, because that's the most important thing of what your contractor wants to do. And you can send it to me or Nikki or somebody, and we can look at that and make sure, number one, it's a cold climate, because we don't give you $600 for a standard heat pump. And then that we can look at what size they are. And then we can tell you what the rebate would be. We also have, what many of you have electric water heaters, which, believe it or not, that's your second biggest use in your home, next to your baseboard heat. That costs about $50 a month to run. So there is actually a heat pump water heater now. And so we runs the same way as that heating and cooling heat pump does, but we're offering a $450 rebate for switching out to a heat pump water heater if you are electric. If some of you are gas or propane with us, the rebates are a little more attractive because you're fuel switching, and so your electric bill will actually go up. So you got to remember, you won't get a big gas bill anymore. You'll get a little higher electric bill, where if you're already electric, you're going to get, it's an energy efficiency project, you are going to get the energy savings on your bill. So we have a little different rebates. If you're really confused, just send me your quotes and I'll be happy to look at them. And then are we doing questions next?
Thanks, Mary. I think the next page,
Yep.
we're going to talk real quick about Love Electric.
Ah.
Yeah. So loveelectric.org, this is a statewide website that has been organized by the Beneficial Electrification League of Colorado, and they have lots of great resources there. So even if you are electric baseboard, if you want more resources about heat pumps, this is an excellent website to find some education and resources and information on. If you are wondering what your utility is and you're not in Holy Cross Energy electric territory, but you joined us today, you may also find some other good resources for incentives on this website as well. All of our incentives are on there, but great place to look all over the state. So check it out. And I think next we're going to go to questions. So if anybody has not typed in their questions in the Q&A box, please do, or in the chat. We see the couple questions in chat as well. We're going to ask Dave those questions. But first, don't forget next week, same time, same place, on Tuesday at 5:30, we're going to have another heat pump webinar. But next week, we're going to talk real specifically about what it's like to replace your ducted furnace system with a ducted heat pump instead. So tune in for that if you want to hear more, and you can register at the same place that you registered for this webinar, walkingmountains.org/energy/webinars. So questions, Mary, do you want to pick the first question?
Yeah, here's a great one. And so what do you think about heat pumps that are combos with natural gas heating? Do you recommend them? So we actually refer to those as a hybrid system. So you have a natural gas backup with a electric heat pump. So Dave, what do you think of those?
Well, I mean, they have a role. It's a good, the beauty of it is we have all these technology options. So I would say those combos would be good to consider. It's for existing homes, because sometimes, and really this refers to ducted scenarios, your ducting system might constrain how much you can do with a heat pump. So you might end up doing 70 or 80% with the heat pump and then have the new gas do the other 20%. If you're doing a new home, generally you can go all electric, but in some cases way up in the highest elevations, and depending on the house size, you might end up doing a hybrid system. And particularly if the house size is such that the biggest singular capacity heat pump can't quite do it, then you might do that hybrid combo. So, it's an option worth considering in certain situations. But, all electric heat pumps is very applicable to most situations. So.
And what I'm seeing, so just so you know, Holy Cross, we won't rebate those. So if you get, and many of you are on this webinar because you are heating with electricity and you don't have a gas line. So what the installers do, they do like a 10 kilowatt, which is 10,000 watts, electric resistant backup. So if for some reason your heat pump isn't working, you always have that backup electric resistant. Believe it or not, I know I've gotten emails from homeowners that have these heat pumps. They were working at -20, -16. So good installation and good sizing, and you'll be set for our winters. So, so look for that electric resistant backup versus bringing in a gas line, even for new construction.
It's a good recommendation. Thanks, Mary. Another question we have, does the delivered air temperature drop as the outside air temp goes down? If so, how low can the delivered air go to?
The delivered air, no, the delivered air temperature does not go down. What happens is that compression cycle requires more energy. So, but I will tell you this. If you set the thermostat to 72, and this is true with all heating and cooling systems, there's a range. It's usually 2 degrees. So 72, you set it, as long as the unit keeps it at 70, it considers it satisfied. So with a heat pump and a little electrical backup, like when it's super cold, you say sometimes people say, well, my house isn't quite cold. It's always like a little bit cold. And the reason is the heat pump always tries to run on the heat pump first. It tries to be the most energy efficient as possible. So it's reluctant to try to go to electric resistance heat when it's super cold. the air temperature coming out is still going to be the same, but it just means that if it's at 7, you'll be like, I'm happy, I'm running the heat pump, I'm running the heat pump, I'm happy. I don't really need to go to the electrical unless it drops below 70 and it has trouble. So the way around that case is very simple. You just tap your thermostat up a couple degrees. So the short answer is no, the air temp will be the same. But when it's super cold, it might try to be a little miserly on using the backup.
And so a little secret, because I know with electric baseboard, if you've talked to me or Eileen Wysocki used to do the home energy audits, we tell you to buy a programmable or smart thermostat and set your electric baseboard back, 8-10 degrees, and you can save quite a bit when you're not at home or at night. With these heat pumps, it's similar to running a boiler system. You set them and leave them. And if it's going to be really, really cold, you actually, just like Dave said, you up the temperature so it can kind of prepare for that. So it's a little bit of a learning curve with these heat pumps compared to electric baseboard.
And that's a good point, Mary, is that, so myself, I have a heat pump, and I still like to sleep when it's cool at night a little bit. And the way I do it is I have a programmable thermostat. I set it back like 6 degrees, but in the morning, I don't tell it go right up again. I have it go up in little 2-degree steps. So for example, I say at night, 66, 5 a.m., go to 68, 7 a.m., go to 70. And those little steps, then the heat pump works. If I said go to 66 to 70, it'd be like, oh, I got to keep Dave warm, so I'm going to crank this thing up with all the electric heat. So that's another little trick you can do.
Right. And you use, the more you kind of up and down the temperature, the more electricity you're going to use. So, it's not good to go more than like 2 degrees is what I'm hearing from the manufacturers. So, yeah. Nikki, you want to do the
good tip, Dave?
Yeah.
Another one we have is, what about heat pump water heaters? Can they provide enough heat for hydronic heating?
No, they just don't have enough capacity now. And that's in the future. I mean, there is technologies that can do heat pumps, air source heat pumps for radiant heating. Not baseboards, because they require very high temperature. Let's talk about in-floor radiant. But that technology is mostly deployed over in Europe and Japan. There's some of it in Canada. But the thing is, now in the US, there's just not many people in that business chain. So you'd have a lot of trouble finding anyone who really can do it right now. We expect that in the next 3 to 5 years, more of that new technology will come, hopefully, to Colorado in the mountains, and more people be involved in it, so you can actually get these really high-tech ones for hydronic heat. But right now, not so much. In the last seminar we went through, you can still apply this heat pump technology to radiant homes. The beauty of it with these mini splits is you put them in, and the mini split can do heating all the way down to let's say 20 degrees. Let's say for 9 months of the year, when the clocks change, it starts to get cold. You basically don't really need the radiant that much, because in the swing seasons, like right now, when the day responds, when the outdoor temperature goes up and down every day, the mini splits are great at doing that. They respond very well to that. So that's a strategy with available technology, is to say, okay, I have my radiant, I love it, but I don't really need it when it's mild out. I'll save that for the really cold months, and I'll do this mini split scenario for all the other months, and I get all these other benefits.
Mm-hmm. And stay tuned. We're hoping that, we call them the air to water heat pumps. There's Nordic, there's Arctic. There's a few, but we just don't have any installers in the valleys that are willing to do the air to water heat pumps yet. So right now, the ductless one is kind of your in between until more of that technology comes over.
Yeah. And we have one more question, and there's a little bit more time. If anybody has one or two more questions, please feel free to type them in. One more question. In summer, My house's upper floor needs cooling while the basement is cold and is heated. Will a heat pump with 2 or more zones work, or would I need 2 units?
Okay. Well, you would need 2 units. So you would put 1 unit up in the upstairs and 1 unit in the basement. And they can't work, like one can't be cooling, the other heating, but they could switch really fast. So the way it would do it is, so upstairs in the summer, you want to be cold, you want to be cool, and you set that thermostat and the system says, oh, I need to cool the upstairs. And it would turn on the upstairs unit, cool it off. And then the basement sites might say, I'm a little low, I need to heat. Then the system will switch very quickly. I mean, you won't even notice that it's switching. And then it'll switch to heating for the basement unit, heat that up, satisfy it, then it'll wait for the next command. So you would need 2 units to do that.
So, but you could do it. So sometime again, looking at, because I've seen this in the homes, yeah, where the basements are really chilly and the upstairs they're just so hot. And you don't want to have a really long line set. So it's okay, to put 2 smaller outdoor units, one for the upstairs and one for the basement. And then you could set the up one on the cooling mode and the downstairs, the basement outdoor unit. As long as you've got 2 different outdoor units, you could do heating in the basement and cooling at the same time. But with 1 outdoor unit, you can't heat and cool simultaneously.
But it would respond so fast, you would be happy. I mean, you're not going to spend like a half hour being cold or hot, vice versa. It's quick enough. They would keep them. That 2-degree swing. That's what you would get. That's the most. Like,
What I hear is that there's a lot of options, and
there's a lot of options, and I've seen them all installed. Yep.
That's a good thing. People's houses are different, so it sounds like there's different solutions with heat pumps. So that's good.
Yeah.
Another question that came up, Dave. How do the thermostats you're referring to attach to the inside units? I need 5 to 6 indoor units in our townhome.
So the thermostats are built into the units themselves. And the cool thing is you have remote controls for these units too. It's really nice because you're there and you can just say, I want to lower it down. I want to lower it up. I want it to go lower speed, higher speed all the time to circulate the air, etc. So it's built into the unit, but you have these nice remote controls, which you can actually mount on the wall if you want. But you got these portable remote controls to take care of it. And
there's also a Wi-Fi. You can pay. So the units come with the remote control, but you can pay extra for a Wi-Fi controlled thermostat too. And the MISA, which we recommend for electric baseboard, MISA smart thermostats, they now have one for heat pumps. So.
And Mary, if you were to go that direction, you would need 1 MISA for each indoor unit.
Pretty much, I think, is how they are doing it. Yeah. So. Yep. So you have a lot of options. Just know that each room that has its own indoor unit, you control that room separately, which is another advantage of these mini splits, is that each room, like I like it warmer than maybe somebody else. So you each can choose your temperature. Go to the room where you like that temperature.
Very nice.
Another question, Dave. How much are the filters and how often do they need to be changed?
The filters aren't much, like $20 or something like that. Changing them once a year should be enough. I mean,
you should
now
clean
it's smoky though, but you can clean them too. You can wash them out and stuff. So that's not a big expense. Taking care of those filters. And if you have a couple filters for the unit, cleaning them and stuff should last you a long time.
And it is recommended, like with every heating system, is to get some preventative maintenance every year, like now before the heating season and stuff like that. So it's always good to have your HVAC, your heating and cooling contractor, come out and look at it, make sure the refrigerant is right and all that before we get into the cold winter months.
And just one thing to remind you, and I would recommend, talking to resources. If you're thinking about your house and you have the situation, you say, okay, I got my electric baseboard. I'm thinking of doing these 2 rooms with the mini split. Just send send it in an email to Nikki, Mary, myself, any other references, and say, what do you think about this? And you'll get, we'll send you our best effort at good advice and say, yeah, this is what we think. This is it. Talk to a couple contractors about these ideas. So it really doesn't hurt, especially in the situations with electric heating. This is a great way to go.
Yeah,
Definitely. We're both here to help, all of us,
Yeah.
including those other organizations we had on that other page.
yeah.
And we have one
So
more question. So go ahead,
That's a
Mary.
good one.
You had
Yeah,
another comment.
so here's, although we like to be agnostic here on our manufacturers, what are the top 3 manufacturers of these mini split systems?
Okay, I will show you. Actually, it's in the appendix here.
And you all will get these slides in a couple of days. So
oh, it's going crazy. Anyway, I don't know what it's doing. Oh, it just went nuts. Anyway, in the appendix is a list. So there's Mitsubishi, there's Daikin, there's Samsung,
Fujitsu, LG, Carrier.
LG. So I don't know if you can see it, but here's a few right here.
Yeah. What I can
And a lot
tell
of these are
you, yeah.
like
Yeah.
Carrier, Mitsubishi is with
Mhm.
Carrier, I think. Yeah. So these are for the big ones. You
Mhm.
want to get their cold climate version stuff. Like
Right.
they all have a name. You on their websites. Daikin is called the Aurora. Here, I'll get it back big again so we can see it. No, not anyway.
Yes.
LG is, F Max with L Gred. I don't know why they call it that. Mitsubishi is Hyperheat. Samsung's is Max Heat. So go on to the website, but those are the big ones.
And a lot of contractors have one that they tend to really like. So don't just go on this list, because I have a contractor that loves the Bosch for replacing a furnace with a heat pump. So like Dave said, the most important thing is to make sure they are a cold climate one. And you really got to specify that with the contractor. So we're running into some misunderstandings where people right now want the cooling, but if you really want it to heat year round, then you need to specify that with your contractor.
And these are all good. I wouldn't get hung up on one brand and say to the contractors, I need to have like LG or I need to have Mitsubishi. It's best to get the bids from what they know the best, because if they know the equipment really well, then you're going to get a great system.
Exactly.
All right, it looks like we are at 6:30, and that was a great webinar with some great questions at the end. We did answer all the questions you wrote down, but please don't hesitate to contact any of us if you have more questions, or if you have some bids you want us to look at, or if you'd like a list of contractors, any of those things, we can all help you with that. So I'm going to go ahead and stop the recording now,